Hello everybody. I plan to publish a series of videos where I'm going to try to solve in real life without knowing solutions, challenging math problems from some challenging competitions. Here we have problems from the Junior Balkan Math Olympiad held a week ago in Turkey. So today we are trying to solve problem one inequality for positive real numbers a, b, and c. We have a condition a squared plus b squared plus c squared equal 1/4, and we need to prove a very weird inequality, and it doesn't seem straightforward at all. So we shall try to do something about that. First, we shall try to write down some ideas what we can use here. For sure, we can use a famous inequality between arithmetic and quadratic mean in the form, for example, for a, b, and c. This means that a plus b plus c over 3, which is arithmetic mean, is always less than or equal to quadratic mean, which is square root of a squared plus b squared plus c squared over 3, valid for positive real numbers a, b, and c, which we have. So here we have this value on the right side. So here we have that a plus b plus c over 3 is less than or equal square root of 1/4 over 3, which is altogether 1/12. So this is simply 1 over square root of 12, which is 2 square root of 3. And when we multiply this with 3, we actually know that a plus b plus c is less than or equal to 3 over 2 square root of 3, or if we multiply to get a rational denominator, we obtain actually square root of 3 over 2. So we know that a plus b plus c is less than or equal to that value, with equality if all three numbers are equal. Okay. So with respect to that, we actually know that, for example, a plus b is less than or equal square root of 3 over 2 minus c, which actually means that 1 over a plus b is with reverse inequality greater than or equal to 1 over square root of 3 over 2 minus c, and similar for other sums of two numbers out of this 3abc. So if we look back at our initial inequality, This left-hand side is actually 1 over square root of 1/4 minus a squared plus 1 over square root of 1/4 minus b squared plus 1 over square root of 1/4 minus c squared. And the right hand side, because of this and similar to inequalities, is greater than to this value, so it will be enough to prove inequality like this if we replace here we have square root of 3, and if we replace those denominator with 3 such expressions, so square root of 3 over 2 minus c, square root of 3 over 2 minus a, and square root of 3 over 2 minus b. So if we manage to prove that, we are finished, but it still isn't straightforward. So what can we do now about this? Let us think. Um, we need somehow to connect those values from here with those values here. So what can we do here? So we have a multiplication of 3 values. So maybe we can use a geometric mean. That third root of that product which is a geometric mean, But actually we need to know that these are positive values. Actually, yes, that will be positive values because that is, for example, square root of 3 over 2 minus c is greater than or equal to a plus b, which is greater than 0. So those will be positive numbers. So this is a geometric mean. But so this is in here in denominator. So this value should be greater or equal of the left hand side. So we need actually reverse inequality for this geometric mean. We need that this to be less than or equal to something. So, and this will be less or equal than a mean of any positive order, arithmetic, quadratic, or any positive order. So what kind of mean can we use here? Okay, maybe not this way. Maybe I'm on the wrong track here. Okay, this was idea, but can we have something better here? If I use arithmetic mean, I will simply have the sum of those values. But I will not get anything about such expressions here. Okay. So all A, B, and C are certainly less than 1. Even less than this value square root of 3 over 2. Maybe I give up to solve this without trigonometric functions. I was trying elementary way. Those are problems for elementary school students. So it should be solved with some basic math. Very basic. thinking. Can we take a look separately each term on the left hand side? For example, this one. So this is 1 over square root of b squared plus c squared. And actually we know that square root of b squared plus c squared over 2 now, because we have two numbers, is again greater than b plus c over 2. Or maybe we can, no, let me see. Okay, if we take this to the -1, we get square root of 2 over square root of b squared plus c squared less than or equal to over b plus c. And when we divide by square root of 2, we will get 1 over b squared plus c squared less than or equal, okay, square root of 2 over b plus c. So this is less than, as already stated, square root of 2 over b plus c. Okay, it has some sense. We are now close to this here, at least partially. And so the whole left-hand side L is less than of square root of 2 over b plus c for the first term, plus square root of 2 over a plus c for the second term, plus square root of 2 over a plus b for the third term. So altogether is square root of 2 over 1 over b plus c plus 1 over a plus c plus 1 over a plus b. And so we want to show that this value here is less than or equal to the right hand side, which is actually square root of 2 times 1 over a plus b, b plus c, c plus a. So if we denote this as x, this as y and this as z, we want to show that 1 over x plus 1 y plus 1 over z is less than or equal, this should be determined, this should be proved, less than or 1 over x, y, z. Okay, maybe we are close. We also didn't still use the initial equality that a squared plus b squared plus c squared is 1/4. So maybe we have a chance to prove that this way now. Okay, let me see. So I shall now, okay. Okay, I will try to erase this. Somehow I need to. Okay, I need to take this larger. Okay, even more. That I can effectively erase this, what I don't need anymore. What I don't need anymore. I was on the wrong way first. So this is the inequality which was useful to me so far. But I don't need that either. I already used that. So our last inequality, which we need to prove, is equivalent to x, y, z. So we push that as one fraction. So it will be yz plus xz plus xy less than or equal 1 over xyz. These are all positive numbers, so we can multiply with xyz and maintain inequality. So this is equivalent to yz plus xz plus xy less than or equal to 1. And that is actually equivalent to, okay, maybe we can now simply put what x, y, and z are. Let me see. Yz, for example, will be, okay, let me see what we'll get now here. Yz is actually a plus c times b plus c plus x is a plus b and z is b plus c plus x is a plus b times y, which is a plus c. This should be less than or equal to 1. And when we combine that with initial equality, maybe we have chance to prove this. Okay, I still don't see the end of the solution, but this is equivalent to Okay, let us try to multiply simply. AB plus AC plus BC plus C squared for the first term. Then again AB plus AC plus BC plus B squared for the second term, plus again AB plus AC plus BC plus now A squared for the first term. This should be less than 1, so this is equivalent with this here is 1/4 plus we have 3 times this here, here and here, plus 3 times AB plus AC plus BC less than 1, which is equivalent with AB plus AC plus BC. Okay, 1 minus 1/4, 3/4 divided by 3 less than 1/4. If we can prove that this is also less than 1/4, we will have the proof. Okay. And why is this less than 1/4? Okay. So we need now to prove this. So we know that square root of AB is less than or equal square root of A squared plus B squared over 2, which is actually the mean between an inequality between geometric mean and quadratic mean. And if we square this, we will get equivalently that AB is less than A squared plus B squared over 2. Similarly, we have AC less than or equal A squared plus C squared over 2, and also BC less than or equal B squared plus C squared over 2. And when we sum all this, we obtain that AB plus AC plus BC is less than or equal to what? To exactly A squared plus B squared plus C squared, which is 1/4, and we are done. Okay, at the beginning, I thought that I will not be able to solve this. This was a really not easy problem, even for me with academic degree, actually PhD in mathematics, and I was also former math competitor. But we can now see what those young, talented students were solving a week ago in Turkey. So it was really a challenge for me. So we shall see, can I solve other problems, other 3 problems from this Balkan Math Olympiad, and we shall see that in the next video. I shall publish each problem in the separate video. probably one problem a day in coming days. Thank you for watching. I hope that you enjoyed the solution. I know that it was not easy to follow me, but this is anyway a solution for talented young people who will try to solve such problems and to see how it is not always easy to find a solution. As you can see, I was also on the wrong track in my first attempt to solve, and only in my second attempt I finally get some clue and some light, and I managed to come to the end of this solution. Thank you for watching. See you next time.